Hello and good afternoon kids. Welcome back once again to this short tutorial video for class 7 math under the topic algebraic expressions. So before moving on to the topic, I would like to remind you that those who haven't went through the basic of this chapter, please go through the basics as it is given in the school channel with the name of fundamental concepts and operations, and it must have been written under class 8 math. So the content is same, so therefore I want you to go for the basics first. Okay, if you haven't gone through the basic, you won't understand the topic. So okay, and those who have done the topic, gone through the basic, so let's begin with the exercise. And please, dear kids, I recommend you to go through the basics first in order to understand the chapter. Okay, so in this chapter, that is class 8 math algebraic expressions, exercise 11, that is chapter number 11. So the previous questions from exercise 11a were all from the basics part, so that is why I am just starting from the question number 8. So as soon as you go through the basics, you will get to understand all the previous questions. Okay, so that is why the basics are very important, not only for the previous questions but for the upcoming sums as well. Okay, in this one, that is exercise 11a, question number 8, what we are given here is we are given with the values of the variables. C, A is given as 2, the value of A is given as 2, B is given as 1, and C is given as 10, and we need the sum is given in terms of variables, so we need to find the exact value, that is the constant value for the when the terms are expressed in terms of variables. Okay, so the first one in here is given as C cube. So the value of C was given as 10, so all we need to do is substitute the value of C in the variable. So therefore I have done 10 cube, so 10 cube means 10 into 10 into 10, so 10 into 10 into 10 will give us 1000. Okay, it's quite simple, isn't it? So but remember, dear kids, for the terms like variables, which one is variable, which one is constant, the coefficients and all the relations, and all you need to do is first go through the basics. Okay, now the second one in here is given as 2b whole squared. So the value of b again is given as 1, c1, 2 and b, the constant and the variable, the relation is multiplication. So I have substituted the value of b in here as 1, so 2 into 1 whole square. 2 into 1, as we know, is 2, because whatever is there inside the bracket we need to solve it first according to the BODMAS rule, isn't it? So it is 2 square, that is 2 square means 2 into 2, so 2 into 2 is 4. Okay, the third one in here again is c plus b whole square. Again the value of c is given as 10, the value of b is given as 1, the relation between them is plus, so within the bracket 10 plus 1, that is 11. 11 square means 11 into 11, that is 121. Is it okay? Okay, now the fourth one in here we have is a minus 3 whole square. So the value of a was given as 2. See, as you can see here, it's given as 2, so it is 2 minus 3 whole square. And 2 minus 3, we know which one is greater. Minus 3 is greater, 3 is greater, isn't it? 3 is greater with a negative sign, so opposite signs are subtracted and the sign of greater number follows. So the greater number is 3, the sign is minus, so it is 2 minus 3 is minus 1. So minus 1 square means minus 1 into minus 1, so minus into minus plus, so we don't need to mention the plus sign, isn't it? So 1 into 1 will give us 1. Okay, and so similarly, the fifth one we have here is 1 by 2 c whole cube. So the constant, variable, the relation is multiplication, so 1 by 2 into the value of c, as we know it's 10, given as 10, so the denominator and numerator we can cancel the terms if they are cancelable, isn't it? If they are multiples or factors. So 2 5 times is 10. What we have now here is 5 into 1 is 5, the denominator remains as 1, so no need to write the denominator, isn't it? It can be neglected 1, so 5 cube, so ultimately 5 cube, so 5 cube means we know 5 into 5 into 5, that is 125. Is it okay? And the eighth one, the question number 8 we have here is 3b within the bracket a cube minus c. So 3 and b, the relation again constant and a variable, the relation is multiplication, we know what we need to do here is substitute all the values of the variables, isn't it? So 3 into the value of b is given as 1, so 1 within the bracket a cube, so the value of a is 2 cube, minus c, the value is given as 10, so 10 in here. So after substituting, what we need to do is proceed with the sum, isn't it? 3 into 1, it's 3 outside the bracket, within the bracket 2 cube means 2 into 2 into 2, so minus 10, so 3 again within the bracket, 2 into 2 into 2, multiplication comes first, isn't it? So 22 into 2 will give us 8 minus 10, again 8 minus 10, 10 a greater number with a negative sign, opposite signs are subtracted, so we have here as minus 2. And as you know, the term the bracket means multiplication, so all we need to do is multiply the terms, isn't it? So before going with the multiplication, what are we supposed to do? First we need to multiply the signs, isn't it? So the sign of 3 is plus, so plus into minus, it's minus, 3 into 2, it's 6. Okay, so I hope you guys have understood this one. Okay, and now moving on to the next topic, next one. So what we'll do is we'll go with the addition and subtraction of polynomials. Now this one is very important, see, because the same basics will be followed till class 10 and even to higher levels as well. So these are the basics. So for this sum, basic sum, you need to understand the basics also. So therefore I highly recommend you to go with the basics as well. Okay, so addition and subtraction of polynomials, it can be done in two ways. Number one, first one is known as row method, second one is known as column method. So we'll be doing the both one. Okay, so whichever method you find it easier, you can go with that. Okay, so it's in exercise 11b. So exercise 11b, question number 1. What we have is we need to add up the terms. The terms are given as 8xy, comma 2xy, 9xy. It's monomials, isn't it? Single term. See, 8xy, 2xy, 9xy, monomial. So for row method, it's simple. See, 8xy, all we need to do is add the terms, isn't it? So plus 2xy, so plus 9xy. Now simple, what happens in addition is all you need to do is just deal with the constant terms, the coefficients, remember. So 8 plus 2, it's 10, 10 plus 9, it's 19, so it is 19 in here, 19. The variable will remain as same as it is. See, xy, 19xy, no need to change any variable. The variable won't change, it will remain as it is. Is it okay? It's for addition, remember. And the column method, it's easy one. Column method also, see, all you need to do is place the terms vertically, isn't it? So 8xy, 2xy, 9xy, vertical placement. Like terms they are, remember, like terms only. The like terms can be added or subtracted, not unlike terms, remember. So since all the three terms they are like terms, so 8 plus 2 again, it's 10, 10 plus 9 is 19, so it is 19xy. Okay. For the next one, yes, for the question number 2, what we have in here is we are given with 4 terms, that too 4 monomials. See, 6a, 5a, minus 3a and minus 3. So again simple, going with the row method, 6a plus 5a plus, and within the bracket 3a, because we cannot write two signs together since it has a negative sign, so I have placed the bracket. Is it okay? Plus again 3 with a negative sign, so plus within the bracket 3a. Now see, these two terms, they have the same signs. As we know, same signs are added and the sign remains same, as well as they are like terms. So see, the variables, they are like terms, isn't it? So 6 plus 5, it is 11a. Now plus into minus, we know that bracket means multiplication, so whenever we need to open up the bracket, we need to multiply the terms, isn't it? And when there is sign in the bracket, we need to multiply the signs, isn't it? So plus into minus, it's minus, again plus into minus, it's minus 3. So what we have done so far, we have opened up all the brackets. Now after opening all the bracket, what do I see is the second and the third term. They are like terms as well as with same signs. So we know same signs are added and the sign remains same, isn't it? So minus 3 and minus 3 will give us minus 6a. Now again still we have like term with opposite signs. So we know that opposite signs are subtracted and the sign of greater number follows, isn't it? So for 11, the sign is plus. That means a greater number has a plus sign. So opposite signs, so 11 minus 6 is 5. So 5a, sign of greater number follows, therefore it is plus 5a. Is it okay? Okay, now again, if you go with the column method as well, is same again, the placement has to be vertical at first. I placed vertically, so see 6a, 5a, minus 3a, minus 3, we are adding up the terms, isn't it? So therefore for these two terms again the same thing, same signs will be added. So these two terms will give me 11a, these two terms will give me minus 6a, again two terms, like terms with opposite signs, so we know opposite signs subtracted, sign of greater number follows. So 11 minus 6, it's 5, 5a with a plus sign. Okay. Okay, now in this one, yeah, question number 3, what we have here is 5x squared comma 2x. Now see, though the variables are same but the powers are different, isn't it? Variable, it's xx, the powers are different, isn't it? It's 2, and this one, it has a power 1. So these two terms, they are unlike terms. Now see, as I've already said, unlike terms, they cannot be added or they cannot be subtracted. So if you are given with the addition of unlike terms, all you can do here is simply place the sign in between them. See, the row method, 5x squared plus 2x, and we are done here. Since they are unlike terms, we cannot go further. Okay. Okay, now similarly the column method as well. So 5x squared plus 2x, so unlike terms, 5x squared plus 2x, so done. Okay. Okay, now the next one we have here is in terms of decimals. So as I said, whenever you go for addition or subtraction of terms, you need to check whether they are like terms or not, isn't it? And how do we know whether they are like terms or not? By looking at the variables, not just the variables but the power of the variables as well. So see, what do I see here is x square y, x square y, x square y. So all the variables, it's same. That means all the three terms in here, they're like terms, isn't it? So what we can do, yeah, we can now add or subtract the terms. The second term in here has a negative sign, remember. So while placing in the row method, so what I did was 3.3 x square y plus, it has got a negative sign, so therefore I have to use a bracket. So bracket minus 2.4 x square y plus 6.4 x square y. So now what do I see here is these two terms, they have the same signs, the first term and the third term, isn't it? So we know the same signs are added and the sign remains same. So therefore after adding up these two, we know that. And what happens in addition? The constant terms will be added. Remember, the variable remains same. So 3.3 and 6.4, when you add them up, you'll get 9.7. Opening up the bracket with the second term, plus into minus, it's minus 2.4 x square y. Again, like terms with opposite signs are subtracted and the sign remains same again. So 9.7 minus 2.4 will give you 7.3. The variable remains the same again, so x square y. Is it okay? Okay. And I have done with the fractional form as well. See, for the fractional form, we are given with 4 monomials. See, this one, first, second, third term, all single terms, that is monomials. So in order to approach first, we need to look at the variables, as I said, whether they are like terms or not. So ab cube, and ab cube. So what do we get to know? All these terms, all the 4 terms, they are like terms. That means they can be added or subtracted. After that, what I have done here is I have used the symbol of addition because the sum was under the addition topic. So first term plus second term plus third term and the fourth term. So what do we know here again? First, third, second, first, third and fourth. We have here first, third and fourth with the same signs. So same signs are added and the sign remains same. So again, all we need to do is go with the constant terms, isn't it? So 4 by 5 plus 1 by 2 plus 3 by 4. Now what we know here is how do we add fractions? By taking the LCM and all, isn't it? So that's what I have done here. See, I have taken all the 3 terms, the same signs, so add them up taking the LCM and all, and I got 41 divided by 20. So that is why I have written here 41 divided by 20 AB cube. The variable remains the same. Remember that in case of addition and subtraction, it only changes in case of multiplication and division. Okay, you'll get to know it afterwards. Okay, the second term with the negative sign, plus into minus, it's minus 2 by 3 AB cube. So now we have here again 2 like terms with opposite signs, so it will be subtracted. So again, what I have done here on the rough part, the subtraction of the fractional forms, again taken the LCM and all, got my answer as 83 divided by 60. So 83 divided by 60 EB cube it is. Okay. And yes, for few sums for subtraction as well. For question number 2, 3 we have here as 3 by 5 x square y from 7 by 5 x square y. So in case of subtraction, as soon as the term from comes, we know that the second term comes first, the first term goes second, isn't it? So the same thing happened here. See, I have placed the second term in first. 7 by 5 x square y minus 3 by 5 x square y. So it's now simple subtraction, isn't it? The variables are same, that is they are like terms, so all we need to do is go with the constant terms. We got fractional forms that do like fractions, so simple. 7 minus 3, it is 4. 4 divided by 5, the variable remains the same, x square y. Okay. And again, with question number 6 we have here is minus 18 m square n square from minus 15 m square n square. So the second terms comes first. We are dealing with the subtraction, so minus, and the first term already has a negative sign, so I need to keep it within the bracket. So that's what I have done here. After opening up the bracket, what do I got? Two like terms with opposite signs. See, and as we know, opposite signs are subtracted, the sign of greater number follows. 18 has a greater number with a plus sign, so it is plus 3 m square n square. Okay. And again, for question number 3, in question number 3 we got sums. The question is already given in the column form, so you can simply directly do the sum. Okay. In the column form also, what we have is, see, the last column, in the last column what we have is minus 8 plus 11 and plus 2. These two with the same signs, so it will be added first. It will be 13 plus 13 minus 8, it is plus 5. Okay. These two like terms, see, what we are doing here is we are sorting out the like terms as well. So plus 6a minus 3a, so it will give you plus 3a. Opposite signs are subtracted, sign of greater number follows, greater with a plus sign, so plus 3a. And these two, 6a square, 4a square minus a square. Now these two terms have the same signs, so this will give you 10a square minus a square. The coefficient is 1, we know, isn't it? So 10 minus 1 is 9, so 9a square, so 9a square. Okay. So I hope you could have understood this lesson about the simple addition and subtraction of fractions. For those who haven't, please go through the basics first, then you will get to know, then it will be easier for you to understand the sums regarding the topic, and the remaining will be your homework. So until then, stay safe.